I'm very excited to be here. And today we're going to be talking about one of the things that is happening in this modern day world is that we're being surrounded by events that are being emitted by all these systems around us. So cars and point of sale systems and refrigerators and applications and logs and change data feeds. So all that data is happening around us all the time. One of the challenges we have is in the last 30, 40 years, we've been very complacent with batch processing. And so we've been very used to that, and we're very comfortable in that model. And real time is a little daunting. It's like, I don't know how to handle this torrent of data that's coming at me. So what a lot of folks have done is taken the chicken way and turned that real-time data into batch data and then process it late. Boo, that's bad. No chicken way. So what you really want to do is be able to take advantage of that data and make it into a competitive advantage for you. It's not only competitive against your competitors, but also being able to have faster insights into that data, being able to do predictive analytics instead of post-mortem analytics, and turning that data into your advantage. So as this data is being emitted, there's a lot of capabilities and services and verticals that are emitting that data. So if you look at logistics for supply chain, you want to know where your truck is, what's the status of your trucks? Does it have a flat tire? Is it getting stuck in traffic? Is there a weather issue? For manufacturing, you want to be able to look at the health of your devices and the industrial IoT messages that are coming out. For automotive, cars are emitting data all the time. So we have tons of data coming out of cars, not only like the temperature, the tire pressure, the gas level, but you also have trucking systems so that you understand how the trucks are behaving. And even in automotive, we even have racing systems. So race cars are emitting data all the time, and we're seeing scenarios where car companies for their race cars are emitting real-time data. Financial insurance, you want to be able to do fraud detection. Retail, you have point-of-sale systems and refrigerators. And energy utilities, you saw with the last demo about, you want to understand how the field is working, if your turbos are still executing, and if the fluid is flowing as fast as you think it is. So all these scenarios have real-time data coming out of it that you can take advantage of for your business. So first I'm going to talk about Azure streaming, and we provide the ability for you to go and capture that data. So all this data that's coming at you in real time is from all these devices and applications and logs. You want to be able to capture it. And so you use Event Hubs, Azure Event Hubs, to go and be that front door to capture all that data. It's a very efficient, low latency, high throughput message broker to be able to handle that streaming data. And then you want to be able to process that data. So you use Stream Analytics to go and validate that message, be able to do transformations on it, and then send it to high volume insight systems. So you send it to Azure Data Explorer, and you can do super rich and very fast queries on that data and do different pivots, and of course do more downstream processing. So first I'm going to talk about Azure Event Hubs, and then Anashesh will come out and talk about Stream Analytics. So just as a reminder, Event Hubs is our high volume, low latency streaming broker that is a multi-protocol capability that provides, of course, the Event Hubs SDK, HTTP, and Kafka. So you can take your Kafka client and point it at an Event Hub, and that behaves just like a Kafka topic. We have native integration with Stream Analytics as well as Azure Data Explorer, so you can get your data into those systems as easily as possible. And it's super fast, right? Single-digit latency for messages that are going through that Event Hub. So what I want to talk about is the new things that are coming out for Event Hub. So I gave you a little teaser at the keynote. First, geo-replication. That's it for a second. So geo-replication is now public preview. Technically, it's next week, but it's actually it's rolling out right now. So it starts June 17th, which is next week. And so you get full data replication across multiple regions. So today in Event Hubs, we provide metadata disaster recovery, but now we provide full data replication across multiple regions. We provide both synchronous and asynchronous. That means you can have an RPO 0, or if you have a tolerance for being a little longer, so then you don't have to have that wait time for that extra latency to commit across regions. We can add that tolerance for you. What we also do, for those, how many people use Event Hubs? Yeah. How many have used the DR, the disaster recovery for Event Hubs? No? One, two, few. So one of the things that we did with disaster recovery before, which was just metadata, which means it's just about the settings, is that you could fail one way, but you couldn't fail back. So the idea is that something failed, it's dead, it's gone. We fail over, it's great. Then you have to go create a new pairing with another region. Now, with our data replication, you can go fail to your secondary and fail back and make that the primary and use secondary and fail back and forth, and we'll continue to replicate that data for you. So, we've had a lot of scenarios where customers want to test their failover, and now you can do that, and it works seamlessly. So initially, we're going to have that available next week, and we'll start with the initial set of regions, and we'll continue rolling out over time more and more regions. So very exciting, geo-replication. Next, the Event Hubs emulator. So now we have the ability to take our Azure Event Hubs and put it into a container. So then you can run that container wherever you want. And so it runs both in Windows and Linux, and it has send and receive support for AMQP. Kafka will be coming as well, so you can run that in your dev test environment. And remember, this is only for dev test, it's not for production. You'll have a single container that executes your code, and then you can do complete functional testing of everything that runs in your Azure Event Hub or through your Azure Event Hub. Very exciting. That's a very highly asked for feature. We're very happy to announce that Event Hubs is now 100% Kafka compatible. We've supported Kafka for a long time. It's always been that 95% Kafka. It's like, very few people use this, but we've heard enough friction for customers like, well, you're not quite there. I might use that feature later. So now we can say we're 100% Kafka compatible. The last two things we were missing was the support for Kafka transactions and Kafka Streams API. So now with Kafka transactions, you get exactly one semantics, item potent producers, and message prevention. So you can use transactions for that. And then with the Streams API, which relies on that Kafka transactions, you get this windowing support and timestamp records. So you have nice scenarios for being able to transfer events from one broker to another, for example, and do that all in a transaction. Along with that 100% Kafka compatibility, we also support the latest Kafka API version 3.5, and we continually keep that up to date. So we're making sure that we're staying on top of the Kafka API versions. And just as a reminder, we recently GA'd Kafka compression as well as Kafka group persistence. So now with Event Hubs, you get to go party on Kafka. So 100% Kafka compatibility. You no longer have any worries about it's not really being fully supported. So very exciting. Event Hubs has a schema registry, and we added support for JSON, which is now GA, JSON schema support, as well as protobuf. So we've always had an Avro schema since its inception, but now with protobuf and public preview, JSON schema, and Avro, you're getting more of a complete set of schemas that you can now put into the registry and do validation and small in make your payload smaller as it goes through the Event Hub and create more efficiency with that. So this really gives you that excellent governance across your messaging, so you can ensure you're only receiving and sending and receiving the events that you're supposed to be getting through your Event Hub and through your particular topic. Okay. So I went a little fast because I am between you and your lunch, so we went a little late. But there's a lot more stuff to talk about, but one of the things I want to do is bring out Anashesh. Anashesh is going to come and talk about Azure Stream Analytics. I'll come back out in 7 minutes.
Is that working? Is there any sound?
Hello? Okay.
There we go.
All right. So Azure Stream Analytics, or ASA for short, is a stream processing engine. It comprised of an input, a query, and an output. We have first-class integrations with many Azure services like Event Hub, IoT Hub, Blob Storage, and also we have native integration with Kafka, so you can read data from Kafka and bring it into ASA for ingestion. The transformation layer is based on SQL query language. And with a couple of lines of code, you can easily filter, join, aggregate, and sort data. But you can also extend the SQL query language with JavaScript and C# using user-defined functions, and we'll talk about that a little bit later. We support integration for machine learning, and we'll touch on that, AI and machine learning as well. And you can read data from slower changing data like reference data. So any one ASA job can have one or several destinations that you can write data to, including, for example, writing your transform data to Power BI so that you can visualize your transform data and see insights on that. Or you can write it to other Azure storage services, for example, data lakes, so that you can train machine learning models on that data. All right, so there's many things that set ASA apart from the competition. I'm not going to touch each one of these, but let's talk about some key ones here. Starting with reliability and availability of utmost importance. So ASA has an observed 4 nines availability and reliability with a financially backed 3.9 SLA. And when we talk about high availability and reliability, we're really talking about the physical reality. So we have strategic domain faults. So each cluster VM has a minimum of 3 domain faults. What this means is if you lose a rack at your server, it automatically fails over to another rack. Also, each cluster spans across 3 availability regions. In addition to that, we have distributed automatic checkpointing. So what that means is that checkpointing happens at the local node level. And this makes recovery more optimal, as well as typically your ASA job is running on several nodes. So if you have one node that's restarting, your job is able to process with the other nodes that are running on that job. All right, fun topic, security. So we can spend a lot of time talking about security, but there's only kind of 3 things that I want to highlight here for ASA. One is that we support dedicated clusters, so you have a single tenant deployment and full compute isolation using dedicated clusters. That can be a little bit heavy in terms of costs. So if standing up a dedicated cluster is something that you don't want to do for cost or other reasons, we support native virtual network integration where we containerize your ASA job and inject it directly into your virtual network. And this gives you the same benefits as a dedicated cluster without the hefty cost of standing up a dedicated cluster. And then if you need extra security, we also support customer managed keys, CMKs. And the way this works is we encrypt all the data associated with running your job, and then we store that data in a storage account that you specify for your job for extra security. All right, so let's talk about AI and machine learning. So we talked about this a little bit at the beginning slide. ASA supports anomaly detection out of the box. So there's several functions that we support out of the box, and these are easily invoked in your SQL query language with 1 line of code, instead of you going back and writing a lot of code to be able to do some of these functionalities. Same goes for machine learning. For example, we also support geospatial functions, and I want to call your attention to the right side of the slide. An example of calling a distance geospatial function with 1 line of code, where in this case, we want ASA to generate an event if a car, in this example, C location, is within a specific distance from any gas station, in this case, less than 50 kilometers away. So you're able to call this geospatial function with a single line of code because that's built into ASA. It's easily usable and accessible. But you don't necessarily need to write code to use ASA. We support a drag and drop no-code editor experience in ASA, where you can set up a full streaming pipeline simply through configuration. And we have rich pre-built templates that you can reference, both directly in Azure Portal and in Event Hubs. And these are for common streaming scenarios that's pre-built for you. You can access and set up your full streaming pipeline. We also have very powerful developer and troubleshooting tools. Things like job diagram in VS Code and physical job diagrams. So these give you node level performance information so that, for example, if your ASA job, if there's a bottleneck in your ASA job, these are typically at the node level. And these visualizations tell you which node is the bottleneck in your job, but not only that, they also tell you where in your query to go to try to fix that bottleneck. Other things, monitoring tools like logs, metrics, watermark delay. ASA supports auto scaling. You can set up auto scale so that your job either scales based on a schedule or on a rule that you specify. For example, if your scenario is such that your business cannot tolerate a latency more than 15 seconds, you can set up your auto scale on your job so that when your watermark delay hits that threshold, your job will scale up automatically. Sorry, my voice is a little dry. Last but not least, I want to call your attention to pricing. In 2023, we revamped ASA's pricing. We've always offered usage-based and capacity-based pricing, but we went back, and to be super competitive, we said, okay, the more loads you run on your job, the less you pay per unit of compute. And so we're up there with our competitors now. And one thing that differentiates ASA is that all features are included in everything that you use for ASA. And that's what I have right now. Thank you.
Okay, I'm back. How many are using Fabric today? A couple. How many want to use Fabric? A couple more. Okay. So one of the things that we've done and we've thought about is in Fabric you're doing a lot of data analytics, and it's been classically used for batch processing. But in reality, that data has to go somewhere, and you want to be able to do some analysis on that. And so one of the things that you get to do in Fabric, because Fabric is a SaaS offering, is that you get to have a lot of opinions, and we like opinions. And so what some of those opinions do is it makes it easier for you to actually utilize what we have to offer. And so, as you look at a streaming platform, there's a couple of things that you need, right? You need streaming data acquisition, so a way to get those events. You need to have the ability to do that transformation. We talked about some of that with the Event Hubs and that Stream Analytics. You need to be able to store that data and be able to do rich queries and very fast queries on trillions of rows of data on top of that. And then you want to be able to react to it. So you have streaming data observation and be able to have observers go and look across all that data so your eyeballs don't get too tired looking at monitors. And then, of course, you want to be able to have events that are coming in from the platforms and the clouds from underneath. And then you want to be able to have a cross view across all those events and types, right? And so then, being able to do that, we get to have that opinion about how we accomplish that. So for the portion about the underlying events, we've plugged that on top of the Fabric platform as well as in Azure. So those emit events and they can set them into the Fabric platform. And so what we've done is initially we had, does this work? We had event streams, the Event House or KQL databases, and Data Activator and Reflex already part of Fabric, and it was working super well. So that handled your events, your streaming, your querying, and your observations on top of that. And we introduced connectors. We have now streaming connectors that capture that data and pass it in. And we also have Fabric Pub Sub that we plugged into Fabric, so then we can have a Pub Sub system to go and capture and subscribe to those events coming underneath. And then a real-time hub on top of that to go and discover all the event streams that you have. And because we have an opinionated platform, now we can make this integration a lot simpler for you. So you don't have to worry about how all these component parts fit together. We take care of all that for you. You say, hey, I want a stream that connects to AWS Kinesis, and we make that happen. I want to be able to go query it. And that's all you have to worry about. You don't have to worry about taking all these components apart and how to do that. And for the events, we absorb all those events. We're able to suck in those events, and then you can just simply subscribe to those events within that platform. And then all that's cross-cutting with Copilot, so then you can have utilize Copilot to get greater observations and understanding of your systems and make your build-outs even simpler. And so we took all that opinion and we created what we call real-time intelligence. This was announced at the keynote with Satya at Build just last month. And we were very excited to talk about it. And we had motor car companies come up and share their experiences of using real-time intelligence in Fabric. So what we've done is we've taken the power of the Azure services that we have, which is the Azure Event Hubs for your streaming broker, Azure Event Grid for your discrete pub-sub mechanism, Stream Analytics for doing that event stream processing, then Azure Data Explorer for being able to do that observability. And so we've taken those enterprise real-time data platforms, mushed them together, along with what we have already had in Fabric, which is OneLake, Data Activator, and Power BI, smush those things together to create real-time intelligence, which is this fully integrated low-code experience for being able to do end-to-end streaming and being able to take advantage of all those events that are happening around you. And so one of the benefits of Microsoft Fabric is that it's created this very simple mechanism for how you look at data. And so with Fabric, you have different workloads that run in Fabric, but all using a common user experience, all running on a common architecture, all running with a common business model, and running on top of OneLake, so you have one view and one copy of your data inside of Fabric. So we've abstracted ADLS for you, so you don't have to worry about that. And of course, then we've taken a lot of the learnings that we had from Power BI to create that SaaS platform all in a single offering. And so with real-time intelligence, we've introduced the real-time intelligence workload and the real-time hub so that you can now have this real-time streaming experience, not just batch processing in Fabric. And so now you can do your event-driven and event-source types of workloads in your SaaS opinionated platform. And so if you look at the offering, we center the ability on the real-time hub. From that real-time hub, we make it super easy to discover and acquire your events from disparate systems. So reaching out to AWS or Google or Confluent Kafka, or being able to get change data feeds, and I'll talk about the change data feeds in a moment, and being able to suck all that data into your real-time hub and then do the processing. So then we take advantage of those capabilities that we have, those workloads with an event stream. You can do that processing, transformation, and routing with the KQL databases or event houses. You can get that data into a super fast queryable database, and then you're able to visualize that with dashboards that have been also recently released, as well as being able to act on it. So you can have triggers that react to data that's coming in. For example, my refrigerator is too hot, over the last 5 minutes. You can do that type of analysis, even if you have thousands of refrigerators. You don't have to worry about that yourself. And of course, it's all built on OneLake and powered by AI. So, one of the things that we had to do is we had at the GA of Fabric in last November, we had event streams, KQL databases, and the data activator. Data activator is still in preview, but we added, to make this real-time intelligence, we had to add a lot of more features. So we really took those offerings and stitched them together to create a better experience, a more integrated experience, and more easily accessible way to get to your data. So the first part is your data sources. And so in your data sources, we added new connectors. So I'm going to go back to when I talked about Event Hubs. Event Hubs is the underlying broker for event streams. And that means that we get to take advantage of the Kafka interface. So with that, what we've done is taken the Apache Camel connectors as our starting point for the connectors that we use for streaming, and use that as the new connector infrastructure for being able to do streaming into Fabric. And so with that, those Apache Camel connectors and being able to take advantage of the Kafka Connect interface is that we also get to use Debezium connectors. Debezium connectors gives you the access to change data capture feeds from databases. And so with the new connectors, we added access to AWS Kinesis data streams, as well as Google Pub Sub and Confluent Kafka. With the Debezium connectors, now you have access to data streams from Azure SQL, PostgreSQL, MySQL, and Cosmos DB. So now you have access to all this data that's coming into Fabric. The other thing we did is we took Azure Event Grid, shoved it into Fabric underneath, and empowered Fabric just like we did with Azure. So in Azure, you have Event Grid that can go and listen to all the change events that's happening across all of your Azure services, and then you get to create push subscriptions so you can listen to those events. And so we've done the same thing for Fabric. So we've taken that power and that capability, stuck it into Fabric, and now you get to listen to events coming from Fabric. And so the initial event types that we listen to is workload events. So kind of similar to Azure Resource Group events. So anything that happens, any resource that's created in a workspace, then will emit an event that you can go and listen to. We also added the capability to listen to events from Azure. And so what we've done is taken those Azure events and make them feel like native Fabric events, so then you can subscribe and deal with them in the same way inside of the Fabric ecosystem. And so initially that we took the storage events, so you can listen to blob changes and a new file is being dropped into your storage account, and then added that as the initial Azure events that's published into Fabric. The next part is ingesting and processing. So ingesting and processing is handled by the event streams. Event streams takes Event Hubs and Stream Analytics, mushes them together to give you a kind of end-to-end stream processing experience. And one of the things that we did in the initial version of event streams is we had a very simple designer where you had routes to destinations, and inside that destination, then you can do some processing with the ASA job under the covers. But that was very restrictive in what you could do. So we took that power and put it onto the main canvas. And with doing that, now that you can do content-based routing, so you can send, if you have trucks with license plates coming in as your events, you can then route them based on the state of their license plate to different tables or different databases where they want to go and do that type of routing, as well as being able to do your validation and checking on that. We've improved the transformation operation, so we have a no-code experience for being able to create these transformations and routes, and now we have richer sets of operations that allow you to do, for example, CSVs without headers. We understand those better. You get to change the names of columns for aggregated fields, and so we made a lot of improvements in that space as well. Conceptually, one of the new things that we've added was derived streams. So now that we've lifted the processor to that main canvas, we now can create these derived streams. So if you do transformations and filtering on a stream, you can create from that original stream a new derived stream that someone can now consume. So you can imagine a data engineer does all the heavy lifting of connecting to a particular source, does the initial transformation to a canonical event schema, and then creates a derived stream, and somebody else can come and consume that derived stream. Next, in the analyze and explore, that's taking the power of, under the covers is ADX, both KQL databases and event houses. And we GA'd event house. So event house is a collection of KQL databases. So now you have this concept of event streams to event house. So this is the place where all your events should go. It's an excellent place for time series types of information. We've created real-time dashboards. So now you can have super fast access to trillions of rows of data and be able to visualize that in real time and very quickly. We've also given you the ability to do visual data exploration on top of that. And what that means is you get to do, without writing any KQL queries or code, You get to do different pivots on that data, different aggregations, and you get to do exploratory analysis on that data and see what's happened. And you'll see some of that in the demo. Lastly, for that, we've added Copilot. So how many folks understand KQL? Can write KQL? Some of you. For those that are intimidated or those that do it, some queries could be a little bit more challenging, or some are a little, off put by it because like, oh, it's not quite SQL. Well, what we've done is taken Copilot, so you can take natural language and ask it a question about your KQL database, and it will come up with a KQL query for you. You can put that into your query set, and that has made it so much easier to be able to create those, and you don't have to feel as friction by it. Lastly, we have ACT. And so for ACT, this is where Data Activator comes into play. And Data Activator is a great way for business analysts to go and observe all that data and then be able to create reactions off of it. So Data Activator allows you to listen for these events, and if one of these conditions are met, then you can either send an email, send an IM message in Teams, invoke a Power Automate workflow, and one of the things we added was Fabric Actions. So now you can invoke an entity in Fabric, for example, data pipeline or a notebook to go execute based on the reaction of that entity. One of the other things we've done is made it super simple to create one of these. So before you had to go delve into the experience of Data Activator and create a reflex and understand how to do models for all of your things that you wanted to observe. Now we make a very fast trigger pane, and this is that kind of coming better together experience. So I want to be able to quickly create a trigger and not feel daunted by all those knobs and things I can configure. So we've embedded these trigger panes to make it really quick and easy to create a trigger, as well as being able to add triggers to KQL. So there was already the ability to observe a Power BI dashboard. Now you can do that to KQL dashboard as well. So that's a lot of stuff that we've done. Our team worked incredibly hard to create this better together experience, and to show you what that experience is like and what you get to take advantage of. We'll have Anashesh come back out and show you what's going on.
Okay, mic's working this time. I think I hear it. Yes? Yes? Okay. All right, so for the next 8 minutes, we're going to pretend we work at Contoso.com as either a data engineer or a business analyst, and I'm going to show you how Contoso uses real-time intelligence to solve some common business problems. So I'm on the real-time intelligence homepage, and what I like to do every day or every other day is go to my dashboard, and here I like to see how my business is performing. So I can see total revenue for my business. I can see total number of orders, customer count. I've built this dashboard so I can see what are my top SKUs that are selling, or I can see revenue breakdown by region. But one thing that's kind of standing out to me in this data is I see some spikes here in my number of orders. So I want to kind of investigate further and see what's happening there. So I click on this little icon called Data Exploration. And this has got some filter. I'm going to remove that so I see my raw data associated here. So in the table below, I see sales order IDs, I see customer IDs, I have all the data associated with that particular table. I saw some spikes, some anomalies, so I want to investigate and see what that's about. So through configuration, I'm going to apply aggregation, and I want to see count of sales by, I want to see customer ID, because I suspect I have those spikes. So I'm suspecting some bot activity or some bad guys trying to sabotage my business. So I want to see count of sales by customer ID, and I want to see them if it's bot activity, I want to see them within a 1 minute duration. So I did this configuration setup here, and you can see the KQL preview below of what my query would look like had I just used Kusto to come up with the same results. And I'm going to go ahead and click apply. So what I see in the table below is customer IDs, timestamps within a 1 minute interval, and I see orders placed within a 1 minute interval. So I see the data that I've looked for here. This top part is just saying that I have a lot of data, maximum recommended is 100, that's fine. So to further kind of hone down on those spikes, I'm going to apply a filter. And my filter is going to be count of sales only if they are more than, let's say, 15 within a 1 minute interval. Okay. So now I'm applying this filter, and here I see I have my customer ID, I have my 1 minute intervals, and I see 37 orders, 33 orders, 36 orders, and I see some different customer IDs here. So this is likely not human behavior. It would be hard to place 24 orders in a minute, or my most, it looks like it's 38. And I want to bring your attention to how easy it is for me to find all this information out without writing a single line of code. And I can also visualize this type of data differently. So right now I'm seeing a line chart. Maybe I want to look at it from a column perspective or bar chart or whatever your business logic is that you want to apply. So I see there's some funky behavior going on. There's likely bot activity going on. This is great. My dashboard's giving me that information. Now I want to go to the source of the data. Okay. So I'm going to go to Real-Time Hub, what Kevin just mentioned. So Real-Time Hub is my centralized estate for all streams and tables in my organization. That's the purpose of Real-Time Hub. I have some easy filters up above. So my stream type can be streams or tables. I'm looking for a specific stream here. I can search by owner, who created the stream to begin with. I can search by location. In this case, I'm working for Contoso. So I'm going to filter by that location. And before we dive into the source of the data, I kind of want to give you an overview of what Real-Time Hub, how it functions. So you see 3 tabs here. The first tab is data streams, which we just talked about. Microsoft Sources is going to be all the Microsoft resources that are available for me to easily connect to. And then Fabric Events, I can easily either add Fabric Events into my data streams, or I can set an alert on Fabric Events or Azure Blob Storage Events. Let's quickly kind of go through how easy it is to do that. So if I wanted to add Fabric Workspace Events, I would just click on Trigger. And then from here, I would just select which event type I want to connect to. Okay, but let's exit because I don't want to do that right now. Right now, I want to figure out what's happening with the funky behavior that I was seeing. So I'm going to go ahead and click on the stream that I know that dashboard is using to produce those results. And here in the L2 page of the stream, I see Confluent, the data is coming from Confluent Cloud, and I see that it's being written to Reflex via event stream. I can easily preview the data further here, and I can open event stream directly from here. So Kevin talked about event stream. Let's go ahead and open up event stream. So here I see let's go ahead and ignore that one. So here I see the pipeline. So my data is coming from Confluent Cloud. It's it's going through event streams. It's writing to Reflex, and I can go to edit mode here. And if you haven't seen event streams before, this is kind of like similar to the no-code experience I mentioned. And you can refresh the data, see the shape of your data as it is coming in. And if I needed to add additional sources, I could easily do that here. I would just go to source. These are all the different sources that we support in Fabric today. And it's as easy as filtering it out, choosing what you want to connect to, and then it's a 2-step process to go ahead and connect additional sources to this event stream. Similarly, I could add more destinations, more outputs to my event stream if I wish. But for the purposes of this demo, I want to also show you how easy it is to apply additional transformations live as this data is coming in. So for our bad guys or our suspicious customers, I would want to, if I wanted to just go ahead and, I have those customers' IDs from my dashboard. So if I wanted to group them together, I would simply choose that transformation logic. And then from there, I could just say, these are the bad guys. and I want to aggregate that data to count, and then I want to look up for some reason my data is not loading. So then the data is not loading, but if it did, I would be able to select count, and then for field, I would choose the customer ID field, and then the next field that would pop up would be the ability for me to enter in the IDs that I want to aggregate through this specific stream. So if I went back to Real-Time Hub, and I clicked on that stream the specific stream I've set up previously, so it is so easy for me now to set an alert anytime an event is generated from any of the bots or the customer IDs which I identified in the previous stream. I could easily set an alert through just configuration, have those particular customer IDs be sent to me via email, via Teams, or added as a Fabric run item. And I would just specify my workspace and click create, and that would create the alert so that I get that immediately in my mailbox, in my team. So I know there's bot activity being run, somebody trying to sabotage my business. Okay, and that is a quick demo of real-time intelligence. Thank you.
Switch it back. Yeah. So of course, with streaming, we have all these capabilities available to you. So one of the things you've probably noticed in your integration scenarios is that you're using more and more streaming brokers, event brokers, to go and handle your workloads. And in any integration scenario, you always have to get that data into some observable state. So being able to put it up into some Power BI dashboard, or being able to understand that data in a different way. So we're super excited about the things that we have. I'm going to let you guys go eat lunch, but you can find us out in the hallway and ask us any questions you want. So thank you very much. Thank you, Anashesh.